So today I'm going to be talking about the recent climate, so sort of what we've noticed over the past couple of years, and then also what we can expect in the season ahead. First, I'm going to start off by just briefly mentioning what NACP is. Caitlin already pointed out it's funded by MLA, so that's a lot of like levy money going towards us. So, you know, always use this as a resource because you're using your own money. Queensland government also taxes. And the University of Southern Queensland, we are part of the Drought and Climate Adaptation Program, as is Caitlin at GrazingFutures. NACP is composed of research, development, and extension teams, so we do all three, which is really great. And I head the extension team. We currently have 8 extension officers that we call climate mates, but we've actually just added another 8, so we'll have 16 total, which is really exciting. And they're all regionally based, and a lot of them live on property as well. So why do we do NACP? Well, we found out that for Northern Australia, most of the forecasts were actually not that good. Like the skill wasn't very good. And that was because the models weren't really being optimized for that region. So essentially, you know, we got this team together and now we are working to optimize the models to give Northern Australia better forecasts. So that way producers can hopefully have a bit better information on which to base some of their decisions. So what is this talk all about? So first, like I said, I'm going to review the rainfall for sort of the past, actually I'm going to look at 36 months, some of the likely causes of the lack of rain, and then what we can expect. So these are a couple images from Australian Climate app. I don't know if anybody uses this, but it's a great resource. You can use it online or on your phone. So these are showing the rainfall over the past 36 months at Quilpie Airport and then also Roma Airport. So if we look at the diagram, if we look at the diagram on the left, it's Quilpie Airport. Hopefully everyone can see my pointer. All these little squiggly blue lines are the 36 months worth of rainfall. So this is 1920 to present. Okay. The blue line is the average or median, sorry, it's the median of all of those, or the middle value. And then the red line is what's been observed in the past 36 months. So we can see up until sort of November 2017, it was, you know, bang on that median line. However, from there, it started to be, you know, quite significantly below the median. And so this is 100 years of data. And we're seeing that rainfall is currently in the 16th percentile. So that means out of 100 years, if you lined them up, rainfall totals from lowest to highest, this would be the 16th lowest one. So there are only 15 years where there has been less rainfall than the past 36 months. So Roma, the same idea. And if we look at the percentile here, it says rainfall is at the 7th percentile. So that means 93 years out of the past 100, or, you know, 93 of the past 36 months out of the past 100 have had more rain than the past 36 months. So this is really obviously low. I don't need to tell you guys that. Yeah, so lots of good information here on the Australian Climate app. Well, so, you know, why has this drought been happening? You know, quite a few of you said 2 to 4 years. So I'm going to focus sort of on that 2-year time frame, kind of why the last 2 wet seasons haven't been great. So now lots of us have heard about El Nino Southern Oscillation, specifically the El Nino part of that, which usually brings dry conditions. So it turns out a couple things. The first one is that you don't actually need to have a full-fledged El Nino to have the drier conditions happen. So that's pretty unfortunate, but that's how it goes. And then the second thing that's really interesting is that back not that long ago, about 11 years ago, they realized that there was something interesting going on with warm water temperatures in the central Pacific along the equator. And they realized that this was creating El Nino-like conditions, but it wasn't exactly the same. So they called this thing El Nino Madoki. So Madoki is a Japanese word that means a same but different thing. So if we look at the diagram, the figure that I have on the slide here, we can see the 2 top boxes are showing sea surface temperatures. That's what that SST means, with South America on the right, Australia on the left. So let's look at the one that has September, October, November above it. This is showing what a traditional El Nino pattern looks like in the tropical Pacific. So essentially, we're looking for water right along the equator, because that water temperatures along the equator are what actually drive a lot of our climate, which is really interesting. So we can see it's red, so that means it's warmer than usual. So there's that big red tongue just sticking out there from South America, and then cold water, quite cold water, immediately over Australia. And then if we look at the figure below it, this is showing the changes in precipitation or rainfall, you know, if you just want to use the layman's, in September, October, and November during El Nino events. So we can see that Sydney has quite a lot of rainfall deficit, but then also sort of along the coast, the Cape, into parts of central Queensland, and then sort of up around the top. However, you know, lots of us know we don't get a lot of rain in September, October, November along the top anyway. So what they found out, they kind of did the same thing looking at El Nino Modoki. So we can see the sea surface temperature patterns again, but this time it looks different. So this time, instead of the big red tongue, there's actually cold water right next to South America. There's warm water in the middle of the Pacific near what we call the date line. So that's 180 degrees. So that's between 160 east and 160 west. And then along the equator, it's 0. So you can see this patch of really warm water, and then again, cold water just north of Australia. And when the sea surface temperatures look like this, this is what happens to our rainfall during March, April, and May. So we can see in the lower right, the Modoki box here for rainfall, that a lot more of the coast and into central Queensland, and then especially across sort of the Barkly, those areas are a lot more impacted. And March, April, May, of course, is a really important time for rainfall in these areas. So even though it might not look quite as like dark brown, this is actually a time when people really depend on that rainfall. So it just shows that, you know, El Niños, yes, they impact us, but this Modoki also really impacts us, probably even more in this area. So another thing that can impact our area is the Indian Ocean dipole. So this is essentially like an El Nino, but just in the Indian Ocean. So in the diagram over here, this is a diagram of the positive phase. Okay, and we can see that there's colder than normal water along the equator to the north of Australia, and warmer than normal water off of Africa. So that means Africa gets the rain and we get nothing, which is really frustrating. Like El Nino, it has an opposite phase. In this case, the Indian Ocean dipole has an opposite phase. In this case, it's called a negative phase, but it's actually good for us. So that's when we have unusually warm water north of Australia, and that brings us rain. Unfortunately for Africa, it's cooler than normal over there, so they dry out. And so the reason that I'm mentioning these two things is because now we're going to look at the past couple of wet seasons and what the Pacific Ocean and the Indian Ocean look like. So for the wet season, 2018 to 2019, so 2 years ago, we had El Nino-like conditions in the Pacific. So you can see all of this warm water stretching along the equator from South America. So those are, those are our El Nino-like conditions. We also had a weak Indian Ocean dipole positive event. So that's the one that dries us out. And you can kind of see that, you can't really tell, but it's when it's a bit colder water over here near Indonesia. Okay, so that's what happened in the 2018-2019 season that contributed a lot to that drought. And now here's 2019-2020. So now we have Modoki-like conditions. So here's the date line, 180 degrees and the equator, and we just see that blob of warm water just sitting right there. We can see the cold water just to the north of Australia here. And also we can see this very strong Indian Ocean dipole positive event. So the cold water right there next to Indonesia. So all this cold water kind of along this area really dries us out. And so this is what happened this past wet season. The Indian Ocean dipole event was actually so strong that it delayed the monsoon by like 3 weeks. It's the strongest on record. It was crazy. So that's a summary of what's happened for the past 2 wet seasons. Essentially, the two big drivers, El Nino and the Indian Ocean dipole, have been active, even if they haven't been, well, even if there haven't been full-fledged El Nino events, there have been full-fledged Indian Ocean dipole positive events, and those absolutely contributed to the past 2 seasons being very dry. So, is there good news for the season ahead? I'll tell you in a minute. First off, one thing I wanted to go over really quickly, because it came up this morning. So the difference between mean and median rainfall. So as climate scientists, we prefer to use median, but what's the difference? Okay, so here we have mean rainfall, so by year, or total rainfall from 2000 to 2019. If we add those all together, we get 12,018 millimeters in this case, and if we divide it by 10, divide it by 20 because it's 20 years, we get an average rainfall, I think this is for Georgetown further up north, of just over 600 mils. So that would be our average or our mean. They mean the same thing. However, our median is different. So you can think of it as the midpoint or the middle. So instead of adding all of those up and dividing by the number of years, we rank them from lowest rainfall for the year to highest rainfall for the year, and we figure out what the middle value would be. In this case, the middle value is 537 millimeters. So we can see that's quite a lot less than your mean or your average, which was just over 600. So when you're making on-property decisions, it's much more valuable to use the median rainfall because that's the one that you're more likely to get. The mean can be skewed by some really high rainfall events that don't happen that often. And because we can't have negative rainfall, the mean isn't balanced by any sort of negative value, right? We can only have 0 rainfall. So we can have really high rainfall, but not negative rainfall. And that's why the mean or the average gets skewed, but the median doesn't because it's just a ranking. Great, okay, so now let's talk about the exciting bit, which is the year to come. Everybody likes blue. Look at all that blue on that map. Oh my gosh, doesn't it look so much better than last year? Last year it was just brown, brown, brown. Horrible. So this is the outlook from the Bureau of Meteorology. It is the Rainfall Outlook, and it's the chance of above median for June to August. Here I chose Thargomindah, hope I said that right, as an example. And we can see that, this little box gives you a lot of information. You can get there by hitting this, little magnifying glass, and then you can type in wherever your location is. Okay, so we can see that the median for June, the median amount of rainfall for June to August at Thargomindah is 42 millimeters. The chance of getting more than 42 millimeters is very likely. And then this one's really important, past accuracy. So this tells you how many times in the past this forecast has been correct. And clearly we can see it's been correct most of the time, so it has a high past accuracy. So that's really good. We also have this chance percentage, so 0 to 100% chance, and then this is millimeters along the bottom. So we can actually see that there's probably like a 70% chance of getting at least 50 millimeters, and then probably about a 50-50 chance of getting 100 millimeters between June and August. So that's really good news. Now if we look at July to September, here I chose Quilpie. And we can see we have most of the same information. So the median for July to September at Quilpie is 33 millimeters. We are very likely to be above that, and past accuracy has been very high, so that means that you can trust this forecast. Okay, so if we look at individual months now rather than the season, we can actually see sort of how we can expect the rain to come, because, you know, if we just look at June to August, we say, okay, well, is it mostly going to fall in June, or is it mostly going to fall in August? Well, if we look at just June, we can see that the chance of exceeding median rainfall for, in this case, Quilpie, is still 65 to 70%. So you're still likely. However, we're not at that really dark blue, whereas when we can see July here up at the top, there's a lot more dark blue. So now there's July, and look, now every place except Charlottesville is dark blue. So that's pretty much telling us we have an over 80% chance of exceeding the median. So we're very sure that in July, that's probably when we're going to be likely to exceed those medians. So if it doesn't happen in June, don't panic. We still have July and August, and in this case, it's looking like a bit later into the winter. That's when we're gonna probably see more of those higher rainfall values. Not that we won't get anything in June, but just pointing out that later in the season we're much more certain. Okay, so temperature. We have minimum temperature for June to August on the left. We can see July to September map looks approximately the same. It's just red, which means there's an 80% chance of exceeding median minimum temperatures. On the right, we have maximum temperatures for June to August. We can see July to September looks quite similar as well. And here we have about a 50% chance of exceeding median maximum temperatures. So why do these maps look like this? Well, the minimum temperature looks like this because there's likely to be more cloud due to the rain that we're supposed to get. And so cloud holds in warmth. It's like a big blanket. So if we have clouds overnight, that means that we don't get those temperature drops nearly as much as if there aren't clouds there. So that's why our minimum temperatures are likely to be higher. It's due to clouds. Interestingly enough, the median maximum temperature is probably likely to be higher, or likely to be average, for the same reason. So here we can see, you know, places in this southwest Queensland area, they're sort of average, possibly, yeah, a touch above average, but you know, we're kind of looking at average maximum temperatures. Again, that's probably related to that cloud cover. So now it's blocking the sun from coming in. So the days aren't going to heat up as much, but the nights aren't going to cool down as much either. That's what this is telling us. So where do you find this information? Well, everybody's favorite website, the BOM. And we click on climate and past weather. So you can see it there just below the weather forecasts. And that will bring you to this page, long range weather and climate. And you can see the rainfall outlook up there on the right. So when you click on that, it brings you to this page, climate outlooks, weeks, months, and seasons. The ones I showed were chance of above median. Chance of at least can also be really useful. You know, if you say, oh, look, I really need to get 50 mils by the end of August, what's the chance of that? That's what chance of at least can tell you. Something that's important to look at that I pointed out before is this past accuracy. So when you click on that, this is past accuracy for rainfall. We can see what how frequently in the past this forecast has been correct. So pretty much you want it to be at least 50%. So anything that's white or tan, if you saw a forecast for that area, and you would take it with a grain of salt, because in the past it actually hasn't been correct that frequently. However, we're down here in southwest Queensland, and you can see that it's mostly green. So you can pretty much trust all the forecasts coming out of that region. Maybe not in June. June looked horrible. And part of the reason that June looks so horrible is that we have this thing called the autumn predictability gap. So essentially around sort of April, May, June, sometimes into July, like the oceans are totally disorganized. Like they don't know what they're doing. They haven't developed a pattern that will usually carry on for a few months. And so when the oceans don't know what they're doing, it's a lot harder to know what these long-term forecasts are going to be like. And so usually by July or August, the oceans have organized themselves either into a El Nino, a La Nina, or a neutral state, and then we have a lot more certainty in our forecasts. Okay, well, so, you know, we now know that you look at the BOM forecast, but do you consider other forecasts? So this one is the European Center for Medium Range Weather Forecasting, or the ECMWF. It's a bit easier to say than the other one, which is a bit of a mouthful. But I always suggest, if you have time, I know lots of us are time poor, but checking multiple seasonal forecasts, because if they all look the same, then you have, you know, a bit more faith that they're going to be right. So we're looking at this one. This one's a bit interesting because instead of being just above or below median, so chance of exceeding median, this one is actually a tercile forecast. So if we think back to that median slide, actually I'll just go back to it because we can. Oh, there we are. So look, a tercile, so median, we just ranked them from lowest rainfall to highest and divide it in half. In terciles, we would divide this into 3 equal groups. So out of 20 years, let's say about 7 years in each. So 0 to 521 would be the lowest tercile, 521 to 656 would be the middle tercile, and 656 onwards would be the upper tercile. So that's how we get our terciles. Oh, lots of slides. And I just point that out because terciles are much more useful than median. So median only tells you if it's going to be above or below a certain value, but it doesn't tell you how much above or below that value. It could be 1 millimeter below, 200 millimeters above, like who knows? Whereas in terciles, we have a range, like a very specific range. So they're much more useful and provide much more information. So that's why I really like looking at these ECMWF forecasts. So here we have June, July, August. So that's what we see up in this right-hand corner for 2020. We see that green means it's likely to be in the upper tercile, and browns mean that it's going to be in the lower tercile, and whites is sort of anything else. So we can see for this region, it's mostly in this lime green color, so there's a 50 to 60% chance of being in the upper tercile. That's great news, right? It pretty much confirms what the BALM says. So here now we have July, August, September 2020, and now we have 60 to 70% chance of being in that upper tercile. Oh my gosh, it just gets better. Somebody break out the champagne. Okay, and now August, September, October, again, 60 to 70, some regions 70 to 100% chance of being in the upper tercile. I guess the downside of this map is you can't figure out exactly where you are, but it does give you a really good idea. And then this one, so this is September, October, November. So this is really long range, which is why it's for the whole world and not just Australia. But we can see here we're still in that lime green, so still 50 to 60% chance of the upper tercile all the way through November, which is really great news. Well, what are the terciles, you might ask, because obviously they're not on the map. So I calculated these for Quilpie. So June, July, August. We'll just look at the upper tercile here because that's the likely place where we're going to be. We can see 62 to 145 for June, July, August. July, August, September, you can see, over 48. August, September, October, over 57 mils, and September, October, November, over 94 mils. So really good news. Unless you haven't done your roadworks, maybe get your roadworks done. Maybe by a boat too. No, just joking. I don't know if it's going to flood. Not saying it's going to flood, but anyway. So the importance of this is to know your historical climate data, and you can get this either on the BALM website, the Long Paddock, sorry, not the Long Paddock website, the Climate Arm, so Arm Online, Climate app, that one that I showed you at the beginning. So there are lots of different places, and definitely feel free to send me an email if you want some help sorting that out. Okay, so now the big question is why? Why are we going to get all this rain? Why did it go from dry to wet? Okay, so before we talked about El Nino, well, now we're going to be talking about La Nina. So this is where the stronger trade winds push that warm water that normally sits along the equator closer to Australia. And as we said before, warm water, rain, cold water, dry. So now South America is likely to be dry this coming year, and Australia is likely to get more rain. So we can see how instead of a red tongue here, so I don't know if you recall, but El Nino kind of had like this red tongue look. Now we have a blue tongue, and that's what a La Nina ocean looks like. So they're not saying at this point yet that we are definitely going to have a La Nina, but like El Nino, even if we don't have a full La Nina, we can still have La Nina-like conditions, which cause rainfall. So that's really good news. The other why is there's likely going to be, again, not completely certain, but likely going to be an IOD negative phase, which is a wet phase for us. So that's really good. So again, we see that warm water close to Australia bringing us that rain. So here is a sea surface temperature forecast, and again, it's from ECMWF, and this is for June, July, August. So what I really want to point out here, for all intensive purposes, is the blue just indicates probably colder than usual water, and the red indicates warmer than usual water. So now, of course, there's lots of red. However, there's this blue tongue, right, coming off of South America. So this is our La Nina-like conditions, and we can see it extending all along the equator there. Oh, there we go. Now we can really see it. So it's that big long one over on the left. And then over here, off of Africa and Indonesia, that's where we look for our Indian Ocean dipole. So when it's cold off of Africa and warm off of Indonesia, that's good news for us. And we can see there's a little blue dot off of Africa, and Indonesia is very warm. So this is a good setup for rain right here. Let's look at the next month. So now we're looking at July, August, September forecast. We can see the blue tongue is growing. And also this blue blob off of Africa, also growing. Next month, August, September, October, again, more blue. This is good news. More blue, good news. And now September, October, November, again, good news. Indian Ocean dipole tends to break down in around November, sometimes December, but usually in November. So that's why we see this sort of backing off, but that's fine, not a big deal, because essentially these warm waters will just provide extra moisture for our region. So even after November, we'll still have a bit of extra moisture coming off this ocean. Okay, so where do you find this information? Again, BOM homepage and then climate and past weather. So this is also where we found that rainfall outlook. But now, instead of looking at the rainfall outlook, we're going to look at this ENSO wrap-up, okay? So this ENSO wrap-up, which you can subscribe to, they can just email it to you. I think they send it out once every 2 weeks. Tells you what's going on in the Indian Ocean and in the Pacific Ocean. It tells you all the information in one place, which is really great. So we're going to look at outlooks and the Indian Ocean. These are our forecasts here. Okay, so we'll start on the left with the ENSO wrap-up. So this is our El Nino Southern Oscillation forecast. So we can see there's a line in the middle here. These are sea surface temperatures above or below average. So 0 is just right on the average. And then now we're seeing it's slightly above average at 0.4, but they are predicting that the ocean is going to cool. We can see that cool in this green line. So the black is what's been observed already, so that's already happened, and the green is the forecast. They make it really easy because they label El Nino here on the top. So if the line goes into this red area, it indicates an El Nino. If the line goes into this blue area, it indicates a La Nina, and we can see that's where the line is going. So now what are all these little tiny gray squiggles, you might ask? Well, that's an excellent question. So the BOM uses a model, a climate model, for this forecast. And they don't just run the model once and see what it says. They run the model, let's say, 100 times. And each time they change something just slightly. So they put in the conditions that we currently are observing, but maybe they'll change the sea surface temperature in one area of the Pacific just a teeny tiny bit, or maybe they'll change the winds just a teeny tiny bit. And then they see what the outcomes are when they've made that very slight change. And so we can see the spread of lines shows what the models, if you make little teeny tiny changes, say. And then the green is the average of all of those models. And the reason that they do this, make these little teeny tiny changes, is because there's chaos in our weather system. So we can think that something is going to happen, but then, the butterfly flaps its wings and suddenly, it's changed it just slightly enough to have an outcome that we wouldn't have predicted otherwise. So even though we know a lot about all of our climate systems and everything, there is still, a little bit of unknown that we try to account for by running our models many times. Okay, so now if we look at the one on the right, this is the Indian Ocean dipole, and we can see the same thing. So in December, we were coming out of that positive event. Now we're in neutral conditions, and the average of all the models is expecting us to go into a negative IOD event this coming at the end of winter, beginning of spring. However, in this one, we can see there are lines like all over the place, right? And this is because the Indian Ocean is a lot harder to predict than the Pacific Ocean. So even though the average of all the models is saying negative IOD, there's a lot more uncertainty in this forecast. However, fingers crossed that we do end up with a negative IOD. Okay, so you might be like, oh gosh, this information is super interesting, but I just do not have time to look at every bloody forecast out there. Well, fortunately, that Rainfall Outlook and also the ECMWF seasonal climate forecast and any seasonal climate forecast, it includes all of these things. So ENSO, IOD, the Madden-Julian oscillation when that starts to happen, the oceans, the atmosphere, everything is shoved in to the seasonal climate forecast. So you don't actually have to look at the individual ENSO forecast or the individual IOD forecast. Unless you want to know the reason behind the forecast, then you can. Now on to our final segment, 2 tips that the BOM didn't tell you about, and maybe a secret as well. So the first one, people may have heard about, but maybe not. The word's starting to get out. So if we look at our Bureau of Meteorology webpage, lots of people use MEDI. I know I do. MEDI is the 7-day forecast from the BOM. it tells us what's likely to come. So when we click on that, we can type in our location. Here I used Innisfail because it's always raining there, so it makes a good example. And so we type in that, we hit locate, and then this forecast box pops up, okay? And we see this is what they're predicting for rain. So I downloaded this on Monday, so now we have Tuesday, Wednesday, Thursday's rain for this week. So we can see on Wednesday, the chance of rain is 100%, and it's 25 to 45 millimeters. Thursday, chance of rain 100%, and the rainfall range is 10 to 30 millimeters. Okay, so most people, like me, would read this as there's a 100% chance of 25 to 45 millimeters, right? On Thursday, there's a 100% chance of 10 to 30 millimeters. Okay, well, unfortunately, that is not how you correctly read this, but there's no way to know that unless somebody tells you, so that's why I'm letting you in on this little tip and secret. So in this case, the BALM definition of chance of rain is anything above 0.2 millimeters. So that's measurable rainfall. So there's a 100% chance of above 0.2 millimeters, okay? For the rainfall range, there is a 50% chance of 25 millimeters, and there is a 25% chance of 45 millimeters. Okay, so let's try this again with, let's look at Friday. Okay, so there's a 95% chance of above 0.2 millimeters. There is a 50% chance of 8 millimeters, and there is a 25% chance of 15 millimeters. Mind blown, right? Yeah, so that's how you read this, and I think lots of people have gotten frustrated with this in the past because they would read it the way that you intuitively read it, which is a 100% chance of 10 to 30 millimeters, but that's not at all the case. So please keep that in mind. Any other forecast that uses this, so including the BALM app on your phone, the Elders forecast, the Willy weather forecast, it all means the same thing. So whenever you see chance of rain as a percentage and then the range, this lower value is always 50% chance of, and the upper value is always 25% chance of. And so before you go on thinking that the BALM just makes this stuff up, they do this because they need to have a scientific reason to provide a rainfall range. Like they don't just pluck 10 to 30 millimeters out of the air. Instead, they look at all the forecasts, and 100% of the 100% of the different, the model runs, in this case, not forecast, the model runs that go into a forecast, 100% of the model runs are saying it's going to rain. Okay. 50% of the model runs are saying you're going to get at least 10 mils, and 25% of the model runs are saying you're going to get at least 30 mils. So that's how they get it. They get it based on what the models are saying and the ranges that they're getting. So from 50% of the models on Friday, 95% of the models on Friday said it's going to rain, the model runs. 8% of the model runs, 50% of the model runs said 8 millimeters, and 25% of the model runs said 15 millimeters. So there you go. Everybody else's favorite button here, rain radars. Okay, so here is a rain radar for the Warrego radar. I clicked on the 512 kilometer composite. So something I learned recently in a radar webinar was this, weather observations. I've seen this box, but I never knew what it did. So it says select weather observations in the map features below. Oh gosh, look at that. There are weather observations. I've also turned on roads because I think it just helps. And now we have this. Oh my gosh, this is really interesting. So we can see that there are little arrows and some numbers here. So at Thargomindah Airport, which is here, we can see that the temperature is about 24 degrees, and in this box we see, okay, 23.7. The wind speed is 20 kilometers per hour. That's listed on the map too. The wind is out of the north-northeast. We can see the arrow pointing there, pointing to the direction the wind's going. And there hasn't been any rain since 9 a.m., so that's a green 0. So this can be really helpful if you're looking at your rain radar, because I sometimes get confused about which way the winds are going on these radars. So this way, you have little arrows to point and show you, and you have lots of information really quickly. So I sent this to Caitlin. This is just, it's a PDF document that outlines a lot of useful climate websites and where to find information. She'll send that out to you guys if you're interested. You can also look at nacp.org.au and find my email and send me an email at any time if you have any questions, or my email's right there. Just wanted to say thank you to everybody. I know it's sort of an awkward time, but I do appreciate your time and I appreciate you attending, and definitely feel free to get in touch if you have any questions. I am here to serve. Thank you so much.